Alright, this is the second part of limiting reactants. That we will talk about. So in the first part of this video, I used an analogy to get you to think a little bit more about exactly what a limiting reactant is, what limits, and what is excess, using an example that really didn't deal with chemistry. But in this case, we will talk about the limiting reactant, the theoretical yield, percent yield, and the excess reactant, and how these things can be calculated. So given this equation, this chemical equation, it's balanced. This thing right there. Given this balanced chemical equation, the problem asks to find the theoretical yield of NH3 in grams. So we want the mass of NH3 in grams to calculate the percent yield when 35.8 grams of NH3 is produced, and 3, calculate the excess reactant. Calculate the excess reactant. Now that's something that we have not done in class, was take it a step further. We identified what the excess was, but we did not calculate the excess reactant. So let's look at part 1 of the problem. Find the theoretical yield of NH3 in grams. So point 1, or rule 1, the limiting reactant gives you the theoretical yield. That is rule number 1. So you can see early on, I don't have to ask you to identify the limiting reactant. I can just ask you for the theoretical yield. Now, if you use the wrong reactant to calculate the theoretical yield, you will get it wrong. So you have to know that the limiting reactant gives you the theoretical yield. And the limiting reactant produces the least amount of product. Okay. So notice in this equation we have two products. We have NH3 and H2O. Now we will tell you which product that we're interested in. Normally there's a major product and a minor product, but we could ask you to find the limiting reactant for either product. In this case, we're interested in the major product, or the product that we're trying to make, which is NH3, and water would be a byproduct of this. So just be aware that you can have more than one product, and we should be explicit about which product we're asking you to find a limiting reactant for. So let me erase these couple of notes and get down to calculating the theoretical yield. So I just said that we need to find the limiting reactant in order to calculate the theoretical yield. So let's take a stab at that. So let's start with NO. We have 86.3 grams of NO. So let's convert that to moles of NO. And 1 mole of NO from the molar mass is equal to 30.01 grams of NO. Grams of NO and grams of NO cancel. Now, at this point, we would want to look at the balanced chemical equation. We would want to look at the balanced chemical equation, and we would want to use our mole ratio. So let me write that in red and let that stand out, because we want to look at our balanced chemical equation to get our mole ratio. Now, a lot of students make the mistake of they want to put a 1 here. Just say we want to cancel moles of NO. They want to put a 1 there, 1 mole. And that is incorrect. That is incorrect just to assume you want to put a 1 there. We have to look at what? We have to look at the balanced chemical equation in order to come up with our mole ratio. So we have to look at the stoichiometry here. 2 moles of NO give us 2 moles of NH3. So that's what we have to put here. We have to put 2 moles of NO. See, the units of mole of NO and mole of NO will cancel. Okay? But we have to use the right stoichiometry. So this is 2 moles of NH3. So moles of NO and moles of NO cancel. Now at this point we can stop. We don't have to carry it on into grams. We can stop at this point. We could if we wanted to, but we can stop right here and calculate the number of moles. Okay, so this gives us 2.88 moles of NH3. Okay, so this amount of NO2 should produce this amount of NH3 in moles. Now, our second step is we want to use the second reactant to see how many moles of NH3 that produces. So let's take the amount that we're given. This will be given in the problem. So we have what? 25.6 grams of H2. So we want to go from grams of H2 to moles of H2. So 1 mole of H2 gives us 2.02 grams of H2. Grams of H2 and grams of H2 cancel. I'm going to change pen colors again because I want to emphasize at this point we need to do what? We need to look at our mole to mole ratio from our balanced chemical equation, where 5 moles of NH2 gives us, 5 moles of H2 gives us 2 moles of NH3. Okay, so 2 moles of NH3 gives us 5 moles of that's 5 moles of H2. So moles of H2 and moles of H2 cancel. Now, at this point we can stop. We don't have to carry it out into grams. And let's see what that gives us. That gives us 5.07 moles of NH3. Now, our limiting reactant produces the least amount of moles between the reactants. In this case, we have 2 reactants, and we would compare the 2. It produces the least amount of moles. So, the least amount of moles is this guy. The least amount of moles is this guy. 2.88 is less than 5.07. So the least amount of moles is produced by NO2. So we can say 86.3 grams of NO, is the limiting reactant. That is the limiting reactant at that point. Now, part 1 of the problem says find the theoretical yield of NH3 in grams. This is the theoretical yield of NH3 in moles, not grams. That is the theoretical yield of NH3 in moles. So let me come here at the bottom and erase some of this so we can calculate the theoretical yield of NH3 in grams. Okay. So, we want to take 2.88 moles of NH3 and we want to convert that to grams. So 1 mole of NH3 is equal to 17.03 grams of NH3. Moles of NH3, moles of NH3 cancels. So that gives us 49 grams of NH3. This is our theoretical yield of NH3 in grams. Okay, that is our theoretical NH3. Our theoretical yield of NH3 in grams. Now let me erase a couple of lines here. And let's do number 2. Number 2. Let's figure out the percent yield. So the percent yield is equal to the actual yield over the theoretical that's actual divided by theoretical times 100. So in this case, that would be what? Well, it says this amount is produced from the reaction. Very seldom do we get 100% yield from the reaction because of some error, some impurity, some consequence, and some reactions are just low yield, or very rarely do we get 100% yield. So what we actually calculate from the limiting reactant is the theoretical yield. What we obtain in experiment, or what is produced, is our actual yield. So it says 35.8 grams NH3 is produced. And what do we calculate our theoretical yield to be? This guy down here, and that would be 49 grams of NH3. And we want to multiply that times 100%. So let me calculate that. It's 35.8 divided by 49 times 100. So the yield in this case is 73.1%, which is a good percent yield. So this is the percent. This is the percent yield. Okay. Now, part 3 is quite interesting, since we know that NO is the limiting reactant. By default, the excess reactant is going to be H2. By default, the excess reactant is going to be H2. So we need to How much excess? Exactly how much excess do we have? So that begins again. Now let me erase all of this. We have time to copy. That begins again with the limiting reactant. To calculate the amount of excess, we have to begin again with the limiting reactant. So this is the part we did not do in class, but it was assigned in homework. And I'm going to show you, this is a very quick and easy to do. So if we must start with the limiting reactant, we must start with what we're given in grams. So that's 86.3 grams of NO. The same setup goes. We want to go from grams to moles. So grams of NO and grams of NO cancel. So now we're at this step. We're at this all-important step where again we have to look at the, let me erase this. We have to look at the stoichiometry from our balanced chemical equation to determine the excess. We have to look at the stoichiometry from our balanced chemical equation. So, what do we have? We have 2 moles of NO produces 5 moles of H2. So moles of H2, moles of NO, excuse me, and moles of NO would cancel. This is one more step that we have to do. It's really not that bad. So now we're in moles of H2. We want to go to grams of H2. So 1 mole of H2 gives us 2.02 grams of H2. Moles of H2 and moles of H2 cancel. Okay? So, what we wind up with is 14.5 grams of H2. That is the amount of H2 consumed or needed to react with 86.3 grams of NO. Now, since we found that amount, we have to say, well, what were we given? We know that NO was limiting and H2 was excess, so we were given 25.6 grams of H2. but we only needed 14.5 grams of H2. So we have to subtract. We have to subtract those two numbers in order to determine our excess. So we have to take what we actually consumed in the reaction for H2 and subtract that from the amount of H2 that we were given. So when we subtract that number, we get 11.1 grams of hydrogen. And that is our excess. Okay. So in part one, we found the theoretical yield. Part two, we found the percent yield. And part three, we found the amount of excess reactant. Okay, so keep in mind each step that you have to go through, and please remember the role of your balanced chemical equation. Okay.